YouTube's recommendation AI is one of the most powerful on the planet. But what happens when you need it to follow a really simple rule? It turns out that's a massive engineering challenge. We're going to break down that challenge and the absolutely brilliant solution that made their AI not just smarter, but actually usable at a truly massive scale.
Okay, so let's just dive right in, because it all kicks off with this question that sounds simple, but is actually super tricky. We think of AI as this all-knowing brain, right? But what happens when you ask it to do something basic, like, hey, only recommend videos that were uploaded in the last week? Well, that's where things get really, really complicated.
And to see why, we have to look at this fundamental flaw in the whole new generation of AI recommenders. And this isn't just some small bug, something you can patch. It's baked right into the way these things are designed from the ground up.
So, at the heart of the problem is this incredible new technology called generative retrieval. Now, instead of just searching through a giant catalog of videos, these new models actually generate the identifier for a video piece by piece, token by token. Think of it like an AI literally creating a unique address for a video it just knows you're going to love. It's creative, it's powerful, and it's a bit of a problem.
Because here's the catch. Without any guardrails, this super smart AI is kind of like a brilliant chef who can cook any dish in the world, but completely ignores your allergy list. It will happily recommend a product that's out of stock, suggest a video that's 5 years old, or even hallucinate an item that doesn't even exist. And all of that just wastes a ton of computing power generating total junk. And hey, don't just take my word for it. The researchers who wrote this paper put it pretty bluntly. They said without intervention, their model would confidently generate SIDs, those are just the unique IDs for items that are out of stock, stale, or legally restricted. For a platform like YouTube, that's a disaster. You need to show people stuff they can actually watch.
So, you might be thinking, well, the solution's obvious, right? Just give the AI a list of what's allowed, a simple filter. And that's what everyone thought too. But this is exactly where the engineers hit a massive, massive speed wall.
The issue is a fundamental mismatch, a language barrier, really. The classic, old-school algorithm for this job is called a prefix tree, or a trie, and it works by following a path one step at a time, kind of jumping all over the memory. But modern AI hardware, your TPUs and GPUs, they hate that. They're built for what's called vectorized operations, processing huge, predictable chunks of data all at once. So you have the old logic that's random and scattered, and the new hardware that needs everything to be neat and tidy. They are, as the paper says, fundamentally hostile to each other. And the result of that hostility? A truly catastrophic slowdown. Trying to use that classic method added over 31 milliseconds of lag for every single token the AI generated. That's an eternity in computer time. So let's be super clear. This wasn't just, it's running a little slow. No way. This was a complete and total deal breaker. For a service like YouTube that has to work in real time for billions of people, that kind of latency makes the whole idea completely unusable. So they were stuck. They could either have a smart but totally unreliable AI, or a reliable one that was unusably slow.
So, stuck between a rock and a hard place, they had to invent a third way out. And this led to the absolutely brilliant solution they called static. It's a completely new way of thinking about the problem that's built for modern hardware.
The big aha moment was a total shift in perspective. Instead of trying to force this slow, step-by-step logic onto super-fast hardware, they asked a different question. What if we could translate the entire rulebook into a language the hardware already speaks perfectly? It's like they swapped a creaky old turn-by-turn treasure map for an instant GPS that shows you every possible route, all at once.
And that's exactly what static is. It stands for Sparse Transition Matrix Accelerated Tri-Index, which is a mouthful, I know. But the idea is genius. It takes that big, complex, branching tree of rules and flattens it down into a giant but super efficient map called a sparse matrix. This completely transforms the problem from a slow, one-step-at-a-time process into a single, lightning-fast calculation that GPUs and TPUs were born to do.
The process itself is just elegant. First, way ahead of time, they flatten the rules into this hardware-friendly matrix. Then, when you're actually using YouTube, that slow, step-by-step checking process gets replaced with one single vectorized lookup. And this is crucial, the whole thing happens right on the AI chip itself. No more slow back-and-forth chatter with the CPU that just crippled the old method.
Okay, so that's the theory. It sounds amazing, right? But what actually happens when you unleash this thing on one of the biggest platforms in the entire world? Well, let's take a look at the impact at YouTube scale.
Okay, the numbers here are just wow. They are staggering.
Remember that 31.3 millisecond penalty from the old CPU method, and even another on-chip attempt was just as slow? Well, the new static method adds just 0.033 milliseconds, and no, that is not a typo. It is so fast it's almost impossible to measure.
And this chart just visualizes that difference perfectly. The latency for the old methods, they're these giant towering bars. And static, you can barely even see it. It's that tiny, tiny little sliver right at the bottom. And that is the difference between an idea that's just a cool theory and one that can actually change the world.
So let's put one single number on that difference. That tiny sliver represents a 948 times speedup compared to the old school CPU approach. That's not just an improvement, that's a complete game changer.
And this is really why this matters to all of us. This breakthrough isn't just about raw speed. It's about taking these incredibly powerful new AI models and making them reliable, efficient, and, trustworthy enough to actually power the services we depend on every single day.
And the proof is right here in the results. When they ran a live A/B test on YouTube, forcing the AI to only show fresh videos from the last 7 days, the impact was huge and immediate. Views of those fresh videos shot up by over 5%. And other key metrics, like how often people clicked and how satisfied they were, also got a nice lift. It's simple. A smarter, more reliable AI just leads to a better experience for everyone.
But wait, there's more. The story doesn't even end there, because the team discovered this fantastic bonus win. It turns out this exact same technique could be used to help solve one of the oldest and hardest problems in recommendations, the cold start problem. That's the challenge of how you recommend a brand new item that the AI has never, ever seen before. Just look at this data. When they tested it on some Amazon data sets, a normal AI model had literally a 0% chance of recommending a brand new item it wasn't trained on. 0. But by using static to force the AI to only choose from a list of new items, boom, it suddenly becomes pretty good at it, going from 0 to over 4% recall. It's like giving the AI a catalog of new arrivals it can instantly read and understand. When you really step back and look at it, this whole innovation wasn't just about building a new AI, it was about building a better bridge between classic, time-tested ideas from computer science and the incredibly powerful new hardware we have today. And that leaves us with a really fascinating final thought. What other classic algorithms are out there just waiting for that same spark of reinvention to unlock their true potential in this new age of AI?